September 2025, a month that would be etched in the annals of meteorological history. Hurricane Erin rewrote the rules of what a hurricane can do, defying expectations and challenging our understanding of these powerful storms. This wasn't just another Atlantic storm. Erin's path connected continents, revealing the immense power and unpredictability of our changing climate. From its explosive birth off the coast of Africa to its final gasp over Italy, Erin's journey was a saga of near misses, dramatic turns, and unprecedented impacts. It rapidly intensified into a Category 4 monster, holding the U.S. East Coast in suspense as it churned offshore, threatening to unleash its fury. But Erin's real twist? Instead of fading over cold waters, it merged with another system, tapped into the powerful jet stream, and rocketed toward Europe with renewed energy. This wasn't a dying remnant, it was a re-energized weather bomb, slamming into the British Isles and beyond, leaving a trail of destruction in its wake. Erin brought record rain, damaging winds, and chaos from Ireland to Italy, proving that hurricane impacts are no longer confined to one region, but can span entire continents. Erin's story is a stark warning. In our interconnected world, a storm thousands of miles away can change lives everywhere, reminding us of our shared vulnerability. It's not just a weather report, it's a message about the future we must prepare for, urging us to rethink our approach to climate resilience and disaster preparedness. Erin began as a humble tropical wave off the coast of West Africa in late August 2025, barely noticeable among the countless disturbances that drift off the continent each hurricane season. Most of these waves fizzle out, lost to the vastness of the Atlantic, but this one encountered something different. Abnormally warm ocean waters, shimmering with heat, providing the perfect fuel for a brewing storm. Within just 48 hours, that unremarkable wave transformed, exploding in strength and organization to become Tropical Storm Erin, catching the attention of meteorologists worldwide. The conditions were textbook perfect: low wind shear, a moist atmosphere, and those record-hot ocean temperatures, allowing Erin to rapidly intensify in a matter of hours, not days. Soon, it became a Category 4 hurricane, with sustained winds topping 140 miles per hour, and a classic clear eye at its center, a sign of a truly powerful storm. Satellite images revealed a perfectly structured monster, its spiral bands tightly wound, powered by the unprecedented warmth of the Atlantic. Erin's strength was no accident, it was a direct result of oceans absorbing excess heat from greenhouse gases, storing energy that hurricanes can unleash. The storm's rapid growth was a stark reminder of how climate change is making extreme hurricanes not just possible, but increasingly likely and more frequent. Erin wasn't an outlier, it was a symptom of a planet running a fever, joining a growing list of supercharged storms in recent years. Its journey from a faint whisper off Africa to a roaring Category 4 hurricane was more than a meteorological event. It was a warning of what's to come if warming continues. The oceans are hotter, the storms are stronger, and the stakes for coastal communities are higher than ever before. Erin's explosive rise is a preview of our stormier future, where rapid intensification could become the norm rather than the exception. This is the new normal for hurricane season: more storms, more power, and less time to prepare. The dice are loaded, and storms like Erin are becoming more common, threatening lives and reshaping coastlines. Climate change is rewriting the rules of the Atlantic, and Erin is just one chapter in a much larger story that's still unfolding. As Erin barreled west as a Category 4, anxiety gripped the U.S. East Coast. From Florida to Maine, communities braced for impact, watching the forecast cone with dread. Even offshore, Erin's massive size sent powerful swells crashing onto beaches, causing dangerous surf and severe erosion. Red flags flew, swimming was banned, and lifeguards performed rescues as rip currents turned deadly. Coastal flooding hit cities like Charleston and Norfolk, with roads inundated by salt water. A subtle shift in steering currents spared the coast a direct hit, and the storm turned northeast, passing east of Bermuda. Relief was palpable, but the damage was real: beach erosion, flooding, and lost tourism revenue. Erin proved a hurricane doesn't need to make landfall to be dangerous. Its near miss was a costly reminder of the risks we face every season. The East Coast dodged disaster, but Erin's power was just beginning. The real story was about to unfold across the Atlantic. Just as the East Coast braced for impact, with millions glued to their screens and emergency crews on high alert, the atmosphere took an unexpected turn. A deep trough in the jet stream, like a giant invisible hand, steered Erin north and then sharply northeast, sending the storm safely offshore and sparing the coastline from a direct hit. The Gulf Stream's warm waters swirling beneath Erin allowed the hurricane to maintain its major strength far longer than forecasters had predicted, fueling its core with extra energy. Instead of weakening as it moved away from land, Erin began a dramatic transformation, its structure shifting in real time before the eyes of meteorologists. The storm started interacting with the jet stream, losing its classic tropical symmetry. Its wind field ballooned outward, and its once perfect eye became lopsided, clear signs of an extratropical transition. But Erin wasn't fading away, it was merging with the upper-level trough, tapping into a new potent source of atmospheric energy that would only make it stronger. This rare phasing allowed Erin to plug directly into the powerful mid-latitude storm track, using the jet stream as a superhighway to accelerate and maintain its strength, racing across the open Atlantic. Erin became a true hybrid, a post-tropical cyclone with hurricane-force winds, now aimed straight at Europe, an unusual and alarming trajectory. Most storms lose steam and die in the cold waters of the North Atlantic, but Erin was just getting started. Its transformation was rare, catching even seasoned meteorologists by surprise, and it set the stage for a transatlantic assault that would soon make headlines across 2 continents. The hurricane's second act would be even more dramatic, as it gathered strength and size over the vast ocean. Erin was now a missile, a force of nature on a collision course with Europe, powered by both the lingering heat of the tropics and the relentless energy of the jet stream, a rare and dangerous combination. Europe was in its sights, and the continent was about to face a storm unlike any it had seen in years. As post-tropical cyclone Erin, the storm was bigger and in some ways more dangerous. Its wind field stretched hundreds of miles, with hurricane-force gusts over cold North Atlantic waters. Instead of dying, Erin drew energy from the clash of cold polar and warm subtropical air. It raced eastward, crossing the Atlantic in just days, a rare meteorological feat. Europe had little time to prepare. Erin looked less like a fading remnant and more like a classic North Atlantic winter storm, except it was September and it carried tropical DNA. The storm's journey proved hurricanes can transform, re-energize, and threaten regions far from their origin. Erin was a case study in how tropical and mid-latitude systems can combine explosively. It was a preview of a future where storms travel farther, last longer, and hit new places with devastating force. As Erin barreled toward Europe, agencies in Ireland and the UK issued urgent warnings. The public braced for power outages, travel chaos, and coastal flooding. Erin's arrival was dramatic. Winds over 80 miles per hour battered Ireland's west coast, downing trees and damaging buildings. Massive waves and storm surge battered coastal communities, while torrential rain triggered flash floods. The storm swept into the UK, with Scotland and northern England hit hardest by wind and Wales and the southwest deluged by rain. Some areas saw a month's rain in 24 hours, rivers burst their banks, and emergency services scrambled to respond. Erin's cold front dragged south, bringing severe weather to France, Spain, and especially Italy. In the Mediterranean, the storm's energy sparked violent thunderstorms, flash floods, and landslides. Erin's reach was continental, one storm causing havoc from Dublin to Rome. Europe rarely faces hurricanes, but Erin changed that overnight. The continent was caught off guard by a storm born thousands of miles away. Erin's impact on Ireland and the UK was severe. Tens of thousands lost power as hurricane-force winds toppled trees and battered coastlines. Roads flooded, ferries halted, and island communities were cut off. In Scotland, bridges closed and travel ground to a halt. In England and Wales, relentless rain turned streets into rivers. Emergency services performed rescues as homes and businesses flooded. Farmers suffered millions in losses as crops were flattened and fields waterlogged. Schools closed, trains and flights were canceled, and the economic toll soared. Beyond the numbers, Erin left a psychological scar, a vivid reminder of nature's power. For many, climate change became real as a storm from across the ocean upended daily life. Erin's chaos was a warning. Extreme weather is no longer abstract. While the British Isles reeled, Erin's trailing cold front unleashed chaos in Italy. Warm Mediterranean air collided with cold northern winds, sparking supercell thunderstorms. Flash floods tore through towns, rivers burst banks, and landslides cut off villages. Power outages spread as hail and wind battered the Po Valley's orchards and vineyards. The Mediterranean's warming waters supercharged the storms, turning rain into catastrophe. Erin's Remnants showed that a single storm's downstream effects can be as destructive as its landfall. Italy's deluge was a final, violent act in Erin's saga, a climate-fueled disaster. Hurricane Erin's journey was a signal from our planet, a warning amplified by a warming world. Heavier rain, stronger storms, and rapid intensification are now present-day realities, not future predictions. Erin's power was fueled by record-warm oceans which absorb most of our excess heat. As long as the planet warms, storms like Erin will become more frequent and more intense. Its unusual track and survival across the Atlantic are linked to changes in the jet stream, driven by climate change. Erin turned climate projections into reality, blurring the boundaries of hurricane season. The storm proved our world is deeply interconnected. What happens in one hemisphere can devastate another. Climate change is no longer distant, it's reshaping our weather now. Erin's story is a wake-up call. We must act urgently to build resilience and address the root causes. The next Erin could be even more destructive, unless we change course now.